Just like every other function that we've done, you are able to transform the function by knowing certain patterns. And we're not going to do this real extensively in this lesson, but we are going to do a left-right shift and an up-down shift. So what I've done is I've already graphed the parent function in red to what we're going to do with the blue function down here in a minute. And so the parent function is the red function, and I've graphed it, and I've listed a few points in the XY table just to show you where those points were where I drew dots. The asymptote is in green. It is the line x equals 0, which is the y-axis, and that asymptote will also move when we move the other stuff. So let's see what happens. Something that is considered inside the function moves stuff left and right, and it always moves it kind of the reverse direction of where you think it should go. And so that 3 would be considered inside the function, and that is going to be a right 3 shift. The 4 is outside the function. It's not part of what we're taking the log of. You're only taking the log of the x minus 3, and then the plus 4 is kind of tacked on to the end outside the function. And so that would be an up-down shift, and it goes in the direction you think it would go, where positive is up and negative is down. So up 4, shift there. And so we want to do each of those things to the whole red graph, the parent function, but it's easier if you'll do it point by point and just think of a few properties that happen. So if we take the 1/4 -1 point and we move it 3 right and up 4, so we're taking this point here, we're moving it 3 units to the right, and we're moving it up 4 spaces. It's going to be approximately right there, about 1/4 of the way to the right, and actually 3 up from the x-axis. And then we're going to take the next point, which is 1, 0. We're going to move it 3 to the right and 4 up, and it lands right here. Then we're going to take the last point that I have, which is 4, 1, and we're going to go 3 to the right. This is this point right here. We're going to go 1, 2, 3. Then we're going to go up 1, 2, 3, 4, and we're going to put him here. Now, it's kind of hard to see like where you're going to go. This part isn't too bad because it's going to keep going to the right, and it's going to keep rising just a little bit. But what we need is to know where the new asymptote is. And what you can know about how these work is the asymptote will move with it. So if the whole graph is moving 3 to the right, the asymptote is also moving 3 units to the right. So the new asymptote will be at x equals 0. I mean, not 0, I'm sorry, 3. X equals 3. And so that will help us with the rest of our blue graph, because now we'll know that it's getting closer and closer to that yellow line, but never crossing over, and that's important to know. And so it almost looks like it's going straight down, but it is actually getting closer and closer and closer to the yellow line as it goes down. Whereas this end of the function is going to go to the right, but it doesn't have a horizontal asymptote. It just keeps rising just a little bit at a time, and it's going to keep rising and keep moving to the right. So that's how you would shift a logarithmic function. One more thing they could ask about your final answer is what is the domain and range, and what is the equation of the asymptote. So let's just go over that real quick again. Dolor the robot is my little saying that helps me remember that domain is left to right, the left bound to the right bound. The range is from bottom to top, the bottom boundary to the top boundary. And so what we want to do is look at the domain, which is left to right, and look at just the blue function that we just graphed. So it looks like on the left, it will never go further left than 3. So our left boundary is 3, and it can't include 3 because it's never going to actually touch that line at 3. Then we have the right boundary. It's going right forever and ever, and so we will say positive infinity. And then if you had to write that as an inequality, you would say that x, because we're talking about left and right, x is everything greater than 3. That would be another way of saying the same thing. Then range is bottom to top, and you can see in the blue graph that the bottom is never, and so it's going to negative infinity on the bottom. There's no boundary on the bottom. And then the top boundary, it may look like it's peaking out at, at 6 or something, but it's really not. It's going to keep rising just a little at a time, and just know that the log functions will do that. They'll have an asymptote in one direction, but they won't have an asymptote in the other direction. So it's never going to peak out. It's going to keep rising just a little bit at a time, and it will end up getting higher than 6 eventually. So it is infinity on that end. And the way you would say that, you can't say y is less than or greater than anything in particular, so you just say y can be anything or all real numbers. The asymptote is the yellow line that we drew, and that was a shift of 3 to the right of the original asymptote in green. And by the way, we did shift it right 3 and up 4, but moving a vertical line up and down doesn't do anything, so that's why I only talked about moving it right 3. The asymptote is the line, it's a vertical line, so it's an x equals, and it's x equals 3. That's the equation of the asymptote. You would write x equals 3 to represent a vertical line. And that's it.